Okay, let's talk about a note here. For a function fx, the value fb minus fa over b minus a is the average rate of change. Okay, this is also called the average rate of change. Okay, average rate of change in the interval AB. If st, instead of using f, if you use st is the distance of a moving object, distance function for a moving object, then the average rate of change, or we call average velocity. Okay, average velocity. Okay, I can denote by av. Average velocity is given by sb minus sa over b minus a. So let us do an example for that. Basically what I am saying here is, as I mentioned already, if a function is continuous in the closed interval and the differentiable in the open interval, then you can find a point where the instantaneous rate of change or the instantaneous velocity is equals to the average velocity, okay, in that interval. So let's do this example. The height of a falling object after t seconds is given by st equals to negative 4t squared plus 390. So the question number A says that find the average velocity during the first 2 seconds. So what is the formula for average velocity? So average velocity is equals to SB. So what is the 2 seconds? 2 seconds is basically 0 to 2, right? The first 2 seconds means 0 to 2. So what I do is S2 minus S0 over 2 minus 0, right? What will be S2? You just replace t by 2. What do you get? If you replace t by 2, you will get negative 4 times 4, right? Because 2 square will be 4. And then plus 390. So that will give you 370.4. So if you use calculator, so 370.4 minus, it will be S0. What will be S0? S0 will be just replace t by 0, will be just 390, right? 390 divided by 2. If you use calculator, you will get negative 9.8 meter per second. This is the average velocity you get. Okay. Now the next thing what you do here is use the mean value theorem to verify that at the same time during 0 to 2, at some time during 0 to 2 seconds, the average velocity is equal to the instantaneous velocity. Basically, you want to find out c here. Okay. So since so what I should say here is s of t is continuous on 0 to 2 and differentiable on 0 to 2, then by mean value theorem, there exists a c, so that s prime of c is equals to s of 2 minus s of 0. I'm just using this exact same procedure, right? 2 minus 0. What do you get? This implies, by the way, I had a typo here. It is not negative 4t square. It is negative 4.9 t square. Okay, negative 4.9 t square. So in that way, you will get 370.4. Otherwise, you don't get that. Okay. The first derivative of this will be 2t. The t square will be 2t times negative 4.9 will be negative 9.8 t. But you are trying to find out at c, right? So it will be negative 9.8 c is equals to, what did you get this value? We find out that already, negative 9.8. This is what you got. Now divide both side by, if you divide both side by negative 9.8, what do you get? Negative 9.8, negative 9.8. Basically, you got c equals to 1, right? Because you cancel out those. So at c equals to 1, the average velocity is equals to the instantaneous velocity. Or what that means is after the 1 second, at 1 second, then the instantaneous velocity is equals to the average velocity. So let us look at the last example. What it says is you need to find a function fx, or you say y, whose derivative is given and that pass through the point 0, 4. So it is very easy problem, right? Because if one point is given and if the derivative is given, basically derivative is the slope, right? So what is the equation of the tangent line, or the equation of the line? So it is basically y minus y1 equals to m times x minus x1, right? So so I will do this problem actually two different ways. Y minus y1 equals to m x minus x1. So what do you get? You get y minus y1 is 4 equals to 3x minus 0, right? So what do you get? Y minus 4 equals to 3x. Add 4. Add 4. What do you get? Is y equals to 3x plus 4. So the function fx is basically 3x plus 4. So this is one way of doing that. Let me do alternative way too. Alternative. So although you don't know the antiderivative, you will see that antiderivative in chapter 4, right? So what is given is f prime of x is given as 3. So can you tell me a function whose derivative is 3? So you can think like this, right? F of x may be like this: 3 and then x plus a constant k. What is the derivative of this function? It is 3, right? So that's why I just assume that since the derivative is 3, the function must be like 3 times x. If you find the derivative of x, it will be 1. So 3x plus a constant. It may be 1, 2, 5, 10, 100 like that, right? But what is given there is, what is given is when x equals to 0, y is given as 4, right? You use that. So what you get is 4 is equals to 3 times 0 plus k. So what do you get? K is basically 4, right? Because 3 times 0 is 0. Now you plug in back to fx. Therefore, f of x equals to 3x plus 4. So either way is okay. Okay, but in chapter 4, you will learn how to find the antiderivative of this kind of functions. And then basically this is what we do, but there is a formula to find out the antiderivative. Okay, guys? Thank you.